Good day everyone, myself Apurva Rajkumar and here I am with my 10th project which deals with strain energy calculation. So the body chosen for my project is a lamp in which my top part or the light emitting part is a frustum. I have a cylinder as the holder and I have another cylinder which acts as the base of the lamp. These are its respective parameterization for my first body, my second body and my third body with their respective limits. So next we have to define a displacement vector field and calculate the displacement gradient tensor. So this is my definition of my displacement vector field, and I've taken the gradient of that displacement field to find out my displacement gradient tensor, and I've also taken the transpose in order to calculate my strain tensor. So next we have to calculate my linearized strain, and this approximation holds true for very small deformations. And using this formula, we can calculate my strain tensor. And here is my strain tensor. Next, using my strain tensor, we can easily calculate the stress tensor using this relationship. And this is my calculated stress tensor. So next we have to assume material properties, and the properties assumed by me is the same as the one professor has taken in his MATLAB calculation. And we also have to calculate the strain energy density, which can be given by 1 by 2 times the strain tensor double dot the stress tensor, which when simplified as half times epsilon ij times Sij. And this is my calculated strain energy density. So this is my MATLAB code, and the only new part is this part where we have to define the displacement vector field in terms of the body parameterization, the strain tensor field, the strain tensor in terms of the body parameterization, the Young's modulus, and my Poisson's ratio. Similarly, I've done the same for my second body and my third body. This is my output where we calculate the volume, the strain energy of each and every body part, and then we simply add them to find the total volume and the total strain energy. These are a few snapshots of my model generated by MATLAB. This is my code. I'll show you a quick demo. As you see, the model has been generated, and we can see both the deformed and undeformed shapes. And this is my computed values of volume and strain energy. So the body chosen for my verification is the third body, which is my base, which is a cylinder, and I have also verified the second body as well because the parameterization of both bodies are same. So this is my third body's parameterization. We have the volume Jacobian, and we know that my strain energy is equal to the strain energy density integrated over the volume. So upon substituting the respective values and dV with volume Jacobian times dr d theta dz, we can calculate that my third body's strain energy is equal or approximately equal to the strain energy computed by MATLAB. And since my parameterization of second and third body are really close, we can just change the values of the limits, and we can find the uh, strain energy for my second body as well. And we can also verify that yes, it is pretty close or approximately the same to the my computed value by MATLAB. Thank you.